Hello and welcome back. Here I am. Welcome back to part 2 of this little kind of video slash tutorial slash sort of just taking you behind the scenes. Hopefully this can get you inspired and to show kind of what we've been up to. Keep on top, there we go. What we've been up to with this scene, and maybe to entice you to join us in a forthcoming kind of little workshop where we'll go into all of this into much depth, because it would take a few hours to really go step by step and recreate this and other things from scratch. The idea being to use the incredible power of parametric modeling that we have typically in Rhino or Houdini or Revit. This is really where the things are, and where AI will be significant, no doubt, in the short, in the upcoming future, and so on. So I will be joined by my friend Michael, who we'll be talking to detail about the blueprint, but in this video I wanted to take you a little bit further in depth into how I kind of recreated this workflow from Rhino to Unreal, and then Michael will join us to explain how we kind of put together all this data into Unreal. So thanks for bearing with me, because I'm kind of learning also, especially Grasshopper, and so this is kind of really taking you through my own understanding of it. So I showed it very briefly last time. I'll go a little bit more step by step. I apologize for the kind of spaghetti nature of my network here, and as usual it always looks a little bit more complicated than it is, so I'll take you through it in right now. I'll disable this to kind of show you the step by step. So again, this what I'm showing you here is a sort of a simplified version, if you want, of Steve's original design. And I probably shouldn't point this out, but some of these elements here are not quite matching, and they should all be in Steve's original design. They were all generated from these actual lines that you see here. And as you can see, although again I shouldn't really point out the mistake, they're not exactly matching. So this is because the original Grasshopper script was extremely complicated, a little bit too much for me, and I simplified it in order to get this workflow going, basically. So I really recreated this original shape. And for that, I was able to extract just the simple sort of generating curves, which we have here. And you will notice that it's positioned kind of specific to the 0.000 here in Rhino. So with that, I'm able to generate, so I'll disable the loft for now, to rotate using this polar array curve, polar array, which basically has a count of 10 and an angle of 6.98. I originally thought that this was going to be 2 times pi, but it's not exactly, so I can't quite remember how I got this angle, but hopefully it's not that relevant for now. But it does give a beautiful shape, and I have noticed with Rhino that you do get beautiful shapes. I don't know why. I've even in the past recreated the same in 3ds Max and didn't get the same sort of beautiful kind of curve or surfaces using the lofts for some reason completely unknown to me. So here I'll move one step forward using this loft here, and I'll disable the next one so that, well, we have this basic donut shape, which is actually a little bit flattened. It's not an exact, as you can see here, the section through, if you want, is a little bit elliptical. So I guess that must have been Steve's design. So moving on, I used this node here to how would I describe? Just populate the geometry in a random manner. And so here I actually created two sets of points, but in order to enable us to have a little bit of variation in the blueprint. So I won't go into too much detail now for just keeping time short. But here we have a set of random points basically scattered around the geometry. So we could have just started from there, really created a donut and scattered some points. So the point pun possibly intended, the point being to have some points that we can generate some data from. So in this case, what we need is the location of the point, but we also need the normal, the orientation of it. So that's why I also needed to find out about this new other sort of node here, the BREP closest point, which is a node which is going to enable us to derive the normal, so the angle at which the point is facing, if you want. You can sort of see here. I'm not sure actually you can. So moving on from there, if I had a way to express that with a line, right, I can't find the line, but never mind. The idea here is that we have the point, and then we also have the normal, so the way the point will be oriented. So we kind of want this XYZ information. And then very simply, we generate this list. And one of the things that is important to see, so if you see this on this point here, the list has got a bracket at the beginning and the bracket at the end. I can't point with my mouse because it'll be it'll go away, but we need to remove the bracket at the beginning and at the end. So we use this replace node here to generate a list. So this will be the XYZ coordinate in space. And this will be the angle. So we'll see how Michael cleverly converted this to a rotation vector in Unreal. So same thing, we remove the brackets, and very simply here I stream the destination. So here I give a location on my hard drive and then stream the content, which gives us a CSV file. So those are the CSV files which I got. So one is called location, the other one is called normal. And as you can see here, they are, as you would expect, a set of points. There's 2,000 of them, and I've got two sets. So 2,000. So there's a couple of things that we need to do to these CSV files. I've actually combined them into one. And here we have to have a top line which says the description of what's in that column, and also we need to have a first line which is unique. So here it goes from 0 to 2,000, and the way I got this is I typed the first one 0 and 1, and then when you do this in Excel, it very conveniently created the next batch. So so this is interesting. Okay, so now let me get Michael back, get Michael here to join us, and let's see. All right, Michael is with us. Hello, Michael.
Hello, Fabrice. Hello, everyone.
Hello, everyone. Hope you can't hear that. There's a motorcycle outside. Great. Well, welcome back to this. So I was just going through the kind of the final bits of my export sort of workflow slash routine from
Brilliant.
Rhino, where I was talking about these data, these lists, basically lists of points, and how I sort of reconfigured this CSV file in Excel using Excel basically to generate this list of unique identifiers, a list of points basically, which we need in Unreal, and then the top row and then the points below. And knowing that we have X, Y, and Z, and rotate, pitch, and yaw, which is what we're going to need in Unreal. So, do you want to share your screen now?
Yeah, go for it. There we are. Let me make sure that's the right one. Okay, cool.
There we go.
Can you see that okay?
Yep.
Right, let me just move this zoom bar, which always somehow is in the worst position ever.
If you can talk a little louder, you're a little bit faint.
Yeah. Let me move things a little bit. I'm sorry if my audio is a bit echoey. I'm in a rather large space without any soft furnishings. But what we so if I'm picking up from that point, just one thing that I wanted to say was that within Unreal Engine, we set up things called structs, which enable us to create data tables. I'm not sure if that's something you've already touched upon.
No, I haven't described any of that yet. So we need to define all these sets of this set of information that we're going to import first, right?
Brilliant, exactly. And a struct gives you the ability to do that. Now, a struct itself is a series of variables in a list. And just one tip that I use to be able to have a kind of cleaner way of importing data is that initially I will create a struct. And in this instance, I've got a struct just of floats. But as you'll see here, it can be all sorts of different variables. But for our locations and rotations, I have X, Y, and Z. Then I have roll, pitch, and yaw. Ignore the other ones, that was for UV space, but if we just concentrate on those first 6 listings, they are effectively 6 columns in the data table. And if I look at that data table, this is the one that I've imported from Fabrice. So we can see that my X, Y, Z, and roll, pitch, yaw take up the first 6 columns in that data table. Now, one tip to share is that if you want to have a kind of cleaner way of importing data into Unreal Engine, what I tend to do is I would create my struct first, and I would create a dummy data table with just some entrance in it and export that out so that I then have a reference in exactly how Unreal Engine handles that data, and therefore that enables me to set up that data table for a clean import.
So it's how do you export that out? Engineering.
So when you have your data table here, for example, you can right click and you can just say export as CSV.
Simple.
So once you have that as a CSV, you can open it in Excel and see how a vector is formatted, how a static mesh is referenced. In our instance, it's just floats, so it's just numbers and decimal points. So, that's just a quick tip around that. Now, in terms of how we then worked with those data points, in the export that Fabrice gave me initially, we were working with 5,800. This is what I then used to be able to create the blueprint that uses instant static mesh. And within that static mesh, I have got a mesh which is then instanced in that blueprint. And subsequently, this mesh then is used as a basis from which to create get rid of that flashing for some reason.
Yes, I get that sometimes.
because I've got a vertex animation. And then this material is designed specifically to work with this mesh. I'll get into that in a moment, but coming back to the blueprint and the instance static mesh, in the construction script, I have created a variable here, which is called DT points. And in DT points, it links back to that data table, the one that I just showed you before. So let me just get rid of that. So what I'm doing for each of the rows in that data table, I'm saying, okay, give me the column that property name X, and I'm adding that into an array called X. So I'm doing that for X, Y, and Z. So just get data table column string.
Can I just pause you in a sec? You skipped that first one, which was set static mesh. So this is just declaring that umbrella model, right? In the construction script.
Basically, so in here I have got my exposed static mesh set here, so that I can change that to anything basically, and it's going to update the instances to now it's a queue.
Oh, I see. Great. Yeah.
And now,
so that's exposed dynamically inside the. Wow! Look at that.
Exactly. So if I come back to here, so I have the instance static mesh component, which is where the superpower is in terms of being able to handle multiple instances of the same static mesh, because all it's doing is loading the geometry once, and then it's just placing that in many transforms. So it's much more performant way of handling multiples of the same mesh. So that instance static mesh component is the target. And here my ISM, which is the static mesh that I'm nominating, in the variables, I've just got it set here to instance editable, which means that back out here.
Oh, you'd frozen for a sec. We've got little connection issues.
How's things now?
Yeah, you're back.
I'm back. Cool. Sorry, it said my connection is unstable.
Oh, there you go.
Welcome to... No?
Yeah, you're back.
I'm back. Okay. So, get data table column as string is the one that we're really using here, and defining what the property name is by the column name data table created. So for our locations, we have X, Y, and Z, and each of those is being put into an array, a string array. For rotations, we had my kind of abbreviated R, P, and YA for roll, pitch, and yaw. In a similar vein, I'm putting those into an array of strings. So each of those is taking the full column. So here, if I come back to the data table, so X, for example, has got thousands of entries, 5,800 entries. Because I'm saying bring in that full column, it's adding each of those cells into
the entire column at once. So that's very efficient.
Entire column at once. So X, Y, Z, R, P, yaw. So those 6 columns are being promoted to arrays here in the construction script. What I'm then doing is saying, taking that same data table, DT points, I'm saying get data table row names and promoting that to a variable. So the row names in this instance are just numbers that are sequential from 0 to 5,800. But what that enables me to do is it gives me the full list, no empty cells. It just defines how many there are. And what I'm doing is I'm saying with those names, all I'm using it for really is to say that each of those rows so I don't miss any at all, create a for each loop. So the for each loop then sets the array index. So the first time the loop happens, it's 0, 1, goes on to 1, 2, 3, all the way up to 5,800. And as that loop runs, this array index gets updated. But I am then using that array index to get the value in those predefined arrays. So now, when this array index is 0, because 0 is the first row, I'm saying those long lists of X, Y, and Z, X get array index at 0. So I'm getting the first row, and then I'm making that the instance transform X location. So I'm doing the same, and the reason that it's so far apart, I'll explain in a second down here for the rotations. But ultimately, this for loop runs 5,800 times. So when this array index is 100, it's getting the 100th entry in X. And because we're using the add instance node, every time that for loop runs, again, 5,800 times, we're adding an instance of the instance static mesh that we defined, but updating the transform location based on the transformed X, Y, and Z in those arrays. Does that make sense?
Yeah, makes sense to me. I'm sure people might be a little bit lost by now, but I guess that's why we'll do the workshop, and then we'll take everything step by step into much simpler examples to build it up from scratch.
Exactly. Yeah. So this is now kind of just about efficiencies and working with lists and kind of carving up columns and rows of data so that you can create blueprint nodes that are much more efficient and do all the heavy lifting. By having this for loop, it's running through this code 5,800 times, so we're not having to do that manually.
Yeah.
And once you've got those kind of key concepts in place, it becomes very, very powerful to be able to create things at scale. And, you know, with this instance, with this example rather, we're using it in combination with a few other techniques that suddenly make something that would seem quite a sort of daunting undertaking in terms of these 5,800 satellites animating into something much, much more manageable and much more performant from a real-time playback perspective.
Right. So basically, this is kind of Unreal sort of eats that up for breakfast in terms of number of instances.
Loves it because Unreal loves instancing, and that's where its efficiencies are really kind of under the hood. It's all about how efficiently it can work with instancing, and go into vertex shading and everything else. But it's a few techniques in combination. You know, when Fabrice contacted me and said, look, I've got this problem, how would you go about solving it? And it was incredibly timely because it was when I kind of just discovered, been playing around much more with vertex shading. I've known and worked quite a lot with data tables, but also the instant static mesh component and the power of
and that was the key.
Relatively.
So
those elements together have made this problem.
Cool. So just for people who may want to try this at home, there's a couple of sort of essential tips to make this work, which is what we're looking at here at the bottom right hand of your screen, which is that make vector, because we output from Rhino, I think it's radians, if I'm not mistaken, and angles. And in the trick that caught me was that we needed to convert that data into a rotation, which is what Unreal likes.
Yeah, but that's not quite right. Sorry.
Yeah, no.
That's what we thought. That's what we thought was going on. So let me explain what's going on here, because this is slightly different. Because it wasn't a radian that was being exported from Grasshopper. It was a distance vector, and I'll explain what that is in a second. So so that's how we've dealt with locations. We've just fed that into X.
Yeah.
So in a similar vein, We, for the rotations, again, these long arrays of 5,800 entrants, we're getting each one in turn and then making that into a vector, because what this vector is known as a distance vector. No, sorry, a directional vector. And in effect, it's the position of the normal.
Yeah.
It's where the normal is pointing in relation to the surface of the torus. But the way the Unreal Engine handles a normal, it's also known as a forward vector. It's what is pointing in that direction. Because of the coordinate system in Unreal where X is forward, we have to take this vector, which is now the forward vector, and we make a rotation from axes, knowing that knowing that this now recombined is the forward vector. We plug that into forward because that is the direction of the normal. But what Unreal Engine can do, knowing that information, it can derive the other two, the right vector and the up vector, from the forward vector, from the X vector. So the forward vector and the X vector are the same thing in principle. So what we do here is when I've gone get right vector, which isn't something let me do now, get right vector, it's added this node here, rotation from X vector.
Oh yeah, so, it wasn't, Zoom wasn't really catching up, but
where are we at then?
So
should I do that bit?
Yeah.
Okay. So from what point? So knowing that this is a forward vector or an X vector or a normal, it's those three things, they're interchangeable. We can plug that straight into the forward of the make rotation about from axis mode. But what Unreal Engine can do is it can derive the right and the up from the forward direction. And if I want to,
it's not really
get the right node to plug.
Yeah. Okay. It's not really catching up when you did the right click and you created the.
I've not done it yet.
Yeah.
So if I go to get right vector, it is calculating that from the X vector, and then I can plug that in. So these nodes are added automatically.
Ah, okay, yeah. That's the trick.
That's the trick here, because Unreal Engine lets you you can get the forward vector, you can get a right vector, and you can get an up vector. But as you can see, this is a vector and this is a rotator. So this can't plug straight into that.
Sorry, what's a vector and what's a rotator?
This
oh, I see. Okay, the yellow. Blue one, the purple one. So the yellow one needs to plug into the purple one. Yeah, okay.
The yellow one needs to plug into a purple one. Obviously, it can't, so it adds the convert vector to rotator.
That's it. Okay.
Which is known as the rotation from X vector. So that's slightly kind of under the hood, but it helps you to be able to plug in these three vectors, which are now your X, your right, and your up, into the make rotation from X.
And then after that, it's pretty. I mean, it's pretty logical.
And then, and then what we had to do is we just had to rotate in the pitch 90 degrees so that the mesh was aligned correctly to the face of each of the points when we've added in the instance transform rotation. So it's actually it's simple in that it's effectively taking a data table, slicing it down into X, Y, Z, pitch roll your arrays, then accessing each of those in turn and adding an instance of the umbrella mesh 5,800 times and setting its transforms.
Fantastic.
So that's what it's doing.
So basically, I mean, that's kind of a principle. I guess we didn't pick the simplest principle to start with, but it was that complexity of having to place these items around the curve of the mesh to solve this issue, which is then enables us to leverage the amazing power of procedural modeling, which is effectively how the scene from the city sample was created using Houdini, and it's effectively that kind of same idea of creating formulas and workflows that enable you to leverage basically a huge number of hours of placing things by hand, and in this case being able to iterate and being able to then work with animation, which I know was something that was a bit of a struggle to then animate. So we'll kind of see how we then animated the materials and stuff like that. So maybe we'll do that some other time, because I guess we've taken quite a bit of time already. Yeah. Oh, I think you've frozen again, Michael. Okay, I think Michael has the Zoom has definitely given up on us, but I hope that was useful for everyone. Oh, there's Michael back. Yeah, you'd frozen. I was just finishing off.
All right.
Yeah, so I hope that was useful for you guys. Again, I understand that it's probably gonna go over most of people's heads, but it's an introduction to a hugely powerful, and I think it's really a taste of things to come for the future when we talk about, how AI is going to revolutionize the world of design and leverage the power of just a few people to do the work of teams and teams of leverage of hundreds of hours of work using this kind of technology. So so stay tuned for more. We'll be back with more of this stuff like that. And again, I'll put a link below if you're interested to dig deeper. We'll with Michael, we've got an upcoming workshop. We haven't set the date just yet, but we will be announcing that very soon. And the idea is really that we'll start from scratch and take things step by step to really, with a view to, well, for us and for me also to understand all this workflow, and to for you to be able to then apply it in your own and develop this knowledge together.
Just to add, it's really exciting that, with a few techniques that working in combination with each other, it's so empowering that Unreal Engine 8 can handle this. But, that donut, that torus example, when Fabrice and I were working on it, at one point we had 12 of those toruses with 6,000 points each, so 72,000 satellites animating in real time at 25 frames per second.
Incredible.
So super exciting. So I think they're really central skills on my laptop.
On your laptop, yeah.
It's the power is there, and with these few techniques, it's really going to feel creatively liberating.
Brilliant. Thank you so much, Michael. Thank you, everybody. See you next time.
Bye for now.
Bye.